In this example we are required to find the moment of inertia of a cylinder of mass m, radius r and length l about an axis passing through its center and perpendicular to its axis. Now in this situation, as the cylinder is rotating about axis y. For calculation of moment of inertia as being a rigid body we need to take up an element. So in this situation, along the axis of this cylinder, we consider an elemental disk at a distance x from the axis of rotation, and, say we consider a width of this disk element is dx. As a total mass of cylinder is m which is distributed uniformly approx the whole length l. You can simply write the mass of elemental disk is. This dm we can write as m by l dx, because whole mass is distributed in the length l. And for the length dx of this length the mass will be m by l dx. Now we find out the moment of inertia of disk about axis of rotation y. In this situation for calculation of moment of inertia of disk about this axis, we'll use parallel axis theorem, in which first we consider an axis parallel to y and passing through the center of the disk. And this axis, if moment of inertia is ic, then about this axis moment of inertia of the same disk can be written as ic plus mx square. So in this situation this moment of inertia of di can be written as dic. This we must consider as dic for the element, plus dmx square. Now dic is the moment of inertia of the disk about this diametrical axis of rotation. And we know for given disk, moment of inertia about diametrical axis is given by 1 by 4 mr square, so this will be 1 by 4 dmr square plus dmx square. So in this situation total moment of inertia of cylinder can be given as integration of this di with the limits of x from minus l by 2 to plus l by 2. This can be written as 1 by 4, integration of dmr square, this m by l r square dx. From minus l by 2 to plus l by 2. Plus m by l x square dx integration. From minus l by 2 to plus l by 2. On integrating here we can see the moment of inertia we are getting is 1 by 4 mr square by l. If we integrate dx the integration will be only x. And we apply limits from minus l by 2 to plus l by 2, plus, here it is m by l integration of x square will be x cubed by 3. Where again we put limits from minus l by 2 to plus l by 2. And on substituting limits, we'll be getting this is l by 2 minus from minus l by 2 is l. So this l gets cancelled out. And we are getting 1 by 4 mr square. Plus, here if we substitute the limits l by 2, so this will be l cubed by 8 multiplied by 3, it'll be l cubed by 24 plus l cubed by 24, it is l cubed by 12, so when l gets cancelled out this will be 1 by 12 ml square. So this is the moment of inertia of this cylinder about the axis which is passing through its center and perpendicular to the axis of cylinder. That will be the answer to our problem. You can also keep the result on your tips, that is 1 by 4 mr square plus 1 by 12 ml square, as a standard result for this situation of a cylinder.